Welcome to episode 8 of the Energy Balance Podcast. I'm Jay Feldman, and today I will be joined by my good friend Mike Fave. Now today we're going to be talking about one of the most important topics from the bioenergetic standpoint, which is the different types of fats. And specifically, we're going to be focusing on the fats that we're typically told are healthy for us, which are the polyunsaturated fats, or PUFA. And these are the omega-3 and omega-6 fats that we find in all sorts of different vegetable oils or in fatty fish and fish oil and nuts and seeds and other foods like that. So we'll be talking about why these fats are actually one of the worst foods that we can eat for our health as far as the bioenergetic standpoint is concerned. And we'll also be talking about the purpose of these fats in the environment and in our bodies and the physiology of how they're so harmful. And then also how they relate to all sorts of different symptoms and conditions, which they are implicated in. So we'll be talking through a little bit of the physiology there, and then which fats we do want to be eating to make sure that we're supporting our health from that bioenergetic view. And the symptoms and conditions affected by these fats include everything from fatigue, weight gain, and any sorts of other low metabolism type symptoms to all sorts of chronic health conditions. Everything from diabetes to cancer to heart disease. These fats have been implicated in all sorts of health conditions. So we'll be talking a little bit about why that is. To check out the show notes for today's episode, head over to jayfeldmanwellness.com/podcast, where I'll be linking to any of the studies or articles that we talk about throughout today's episode. And if you are dealing with any low energy symptoms, whether that's fatigue or brain fog or gut issues or blood sugar dysregulation, or you're not sure what you should be eating to support your health, or if you're dealing with any of those chronic health conditions I mentioned, whether that's diabetes or heart disease, head over to jayfeldmanwellness.com/energy and sign up for a free mini course on energy balance. And in that mini course, I'll be walking you through the different things that you'll want to do to support your health, to support your energy producing systems, and which things you want to avoid to make sure that we don't block that process. And I'll also go into some of the details as far as fats go, but also other macronutrients and everything from movement and exercise to psychological stress. So again, to check that out, head over to jayfeldmanwellness.com/energy, and I'll also have a link to that in the show notes. And with that, let's get started. All right, so we'll start off by talking about the different types of fats and how they differ structurally. So typically the way that we categorize fats is based on their saturation. And so we have saturated and unsaturated fats, and then within the unsaturated fats, there's monounsaturated or polyunsaturated. And so basically what we're talking about when we're talking about the saturation is the amount of hydrogens on the fatty acid chain. And so when the fatty acid chain is entirely full of hydrogens, you could say it's saturated with hydrogens, and so that would be a saturated fat. And then if there are less hydrogens on that on the fatty acid chain, then it would be unsaturated, and that would happen when there are double bonds between the carbons. And so if there's a single double bond, then it would be monounsaturated, and if there are multiple double bonds, then it's polyunsaturated. And so the reason why that's relevant is because that ends up dictating the effects of the different fats on our physiology and just how they function in the environment. So as far as which foods contain the different types of fats, for saturated fats, we're looking at the primarily solid fats at room temperature. And so that would be a lot of different animal fats or dairy fats. So you could think of butter, or on the animal side, like any sort of, ruminant
beef tallow,
beef tallow,
properly fed pigs for lard, properly fed egg chickens for egg yolks.
Mm-hmm. Yeah, so all those are primarily saturated, and because of that, they're more solid at room temperature, and that's
like cocoa butter and things like that as plant fats.
Yeah, coconut oil as well.
Coconut oil, palm kernel oil.
Yeah, and so those fats, because they're more stable, they don't have any of those double bonds. They're more solid at room temperature, and then they also have higher melting points, which is basically the same thing, and they stand up better to heat for the most part. And then as far as the more unsaturated fats go, those are more liquid fats at room temperature. They have a lower melting point. And so that would be monounsaturated fats like olive oil, And then also more polyunsaturated fats, which would be mostly the seed oils. So that would be cottonseed, sunflower seed oil, canola oil, corn oil.
Yeah.
Soy.
Sesame oil, soybean oil.
Yeah. There's basically any of those vegetable oils except for olive oil and coconut oil. And then also some of the animal fats can also be polyunsaturated. So this would be fish that are high in fat, typically have a lot of polyunsaturated fats, as well as chicken or
improperly fed pigs.
Yeah, chicken and pigs that are fed more polyunsaturated fats have more polyunsaturated fats in their own fats. So those, and so the polyunsaturated fats are also known as omega-3s and omega-6s, which is worth mentioning because that's how most people know them. And it's also worth mentioning that with all of these different foods, we're talking about the primary sources of these fats, or which fats are primary in these different foods, but they all have some amount of mixture. So when we're talking about beef tallow, for example, or beef fat, there's a lot of monounsaturated fats in there too, as well as the saturated fats. Coconut oil, on the other hand, is mostly saturated. There are very few mono or polyunsaturated in there.
Yeah.
So that's just kind of a general primer of what these different fats are, where they're found, and their different properties.
Yeah.
And then that becomes very relevant when we look at how these fats function in the environment and in biology. So
before we get to that, I think we should put a few caveats or like discuss some of the nuances in there.
Sure.
Just in general. So you said that we have three classifications. To summarize, we have three classifications of fats. You have saturated fats, monounsaturated fats, and polyunsaturated fats. The way I like to see them is they're sort of on like almost like a gradient, with saturated being the best, and then monounsaturated being not so bad, about neutral, and then polyunsaturated being very problematic. So we said within saturated, we have butter, beef tallow, cocoa butter, coconut oil, palm kernel oil. Then for monounsaturated, we have olive oil and macadamia nut oil,
and avocado,
and avocado, and then or avocado oil. And then after that, we have the polyunsaturated, which is canola oil, corn oil, sesame oil, soybean oil, sunflower oil, safflower oil, all of those types of vegetable oils. So within these groups, people are going to say, well, coconut oil at room temperature is liquid, or palm kernel oil at room temperature is liquid, and stuff like that. And so when we go in to discuss why the polyunsaturated fats are used in certain circumstances, like within fish and things like that, the liquidity aspect is important. And the caveat to this, specifically for the coconut oil and palm kernel oil arguments, which may come up, those are medium chain fats. And the medium chain fats, they have lower melting points than the saturated fats. So they are more liquid at at room temperature. And that's not because their carbon structure or the fatty acid tail and the hydrogens are different. It's just that there's a shorter fatty acid tail or carbon chain, which allows them to be liquid at different temperatures. So different structural effects of the fat have different, like, in real life properties. And the structural effects are very important for determining what the in real life properties are, what you see with the fat overall. And so I think that it's important to make some of those distinctions there. The main importance, the biggest thing that is going to underlie the rest of the conversation going forward is not necessarily the length of the carbon tail, or the length, which is basically the length of the fatty acid tail. It's going to be how many double bonds are in the fatty acid tail, which is what you started with, or what you started saying. And the way I like to see it, and I think it's really helpful, is that when you add that double bond in the carbon and you lose some of the hydrogens, if you think of like musical chairs or something like that, when you create that double bond, you leave an open chair for some sort of peroxidative molecule or oxidizing molecule to come in and break the carbon chain, which is the carbon chain is the fatty acid tail. And the fragments that are created from breaking that chain are toxic to cells and toxic in general overall in physiology. And there are certain contexts and circumstances where the breaking of that chain is more likely to happen or less likely to happen. So I just want to set that up for everybody going forward, that the number of carbon, double bonds between the carbons in the carbon chain of the fatty acid tail is one of the most important points to focus on in terms of understanding the physiology of the different types of fats and why we're choosing saturated or monounsaturated over polyunsaturated, considering our context as warm-blooded mammals.
Yeah, and we'll talk through that context in a second. To back up even further, which maybe would have been helpful to start here, is that most of the mainstream view of these fats is almost opposite of our view. And so in the general health sphere, the heart healthy fats are typically the polyunsaturated fats. And so these are the corn oil fats, or all the fats from grains and nuts and seeds, and fatty fish like salmon, fish oil. Those are all polyunsaturated fats. They're all very high in omega-6s and omega-3s. And what we're talking about is the fact that because of these structural differences between the polyunsaturated fats and the more saturated fats, they're actually pretty detrimental to our health and our physiology. And we'll talk through exactly why that is. But yeah, just as kind of that general overview, what we're saying is essentially that most of this advice in favor of polyunsaturated fats is pretty heavily misguided.
Yeah. On a direct physiologic basis.
Yeah.
Before we go into like the specifics of the animals, I think another important point to lay out for people in general is that when we talk about pigs or chickens having a lot of unsaturated fats in their tissues, that's not, whereas ruminant animals like cows, sheep, or goats usually don't have a lot of unsaturated fat in their tissues. That's not necessarily a rule specific to those organisms, besides ruminants generally not having a lot of unsaturated fats. The only reason that the pigs and the chickens and other fowl have a high amount of unsaturated fats in their tissues, at least from industrial production, is because of the diets that those animals are fed. So I think understanding the different digestive anatomy and physiology between the animals is important. And just like as a brief overview of what goes on, the ruminant animals like cows, sheep, goats, cattle, they have a rumen, which is a large chamber that allows fermentation to occur. And the bacteria in the rumen ferment the fatty acids and any of the plant matter that goes into the cow's rumen. And when they ferment them, they change those fatty acids into saturated fatty acids or into conjugated unsaturated fatty acids, it's called conjugated linoleic acid. That's like a supplement that people take. I'm sure if you're in the bodybuilding community or anything, you've heard about it. It's like a fat burner and has a whole bunch of beneficial effects. I think
it's actually a trans fat.
Yeah, it's a trans fat. I think its importance is because of it's so similar to linoleic acid that it has some like displacing effects and things like that. It's like immaterial for our conversation right now. But the cow and any type of ruminant animal basically ferments the food that goes in. So the bacteria serve as a filter of sorts for the unsaturated fatty acids, whereas the chickens and the pigs' digestive system is set up a bit more similar to ours, where we absorb first and then ferment later. So they absorb the food that goes in first. So any type of unsaturated fat or fatty acid that is in the diet will show up in those animals' tissues. The same thing occurs with us. If we eat a lot of unsaturated fats, it will show up in our tissues. Yeah,
which is definitely an important thing that we'll be talking about. And so it's kind of a good transition. So all of these different fats serve different purposes in nature based on their properties. And so to start with the polyunsaturated fats, there's a few different places that we see them in nature. The first is the first one that we talked about was seeds. So this is seeds, nuts, grains, legumes. These are all parts of seeds, or these are all types of seeds that we consider foods. And so inside of these seeds, the fats that are found are mostly polyunsaturated. And the reason for that is because these seeds are typically, based on their life cycle, they normally have to be inside of under the ground during the colder months of the year. And they need to stay basically intact during that time, and then to be able to sprout in the spring when it starts to get warmer. And so during those cold months, because these polyunsaturated fats are liquid at lower temperatures, whereas a saturated fat would be entirely solid, they serve as basically a better option, or a necessary option, during these colder months. So it basically allows the seeds to hibernate during these months in the cold without while staying alive, and allows them.
The seed is relying on the fatty acids for like an energy source to some extent to subsist, if I remember correctly.
Yeah.
Or when the seed starts to sprout, it burns through that energy store in order to basically create the beginning of the plant.
Right.
The polyunsaturated fats allow the seeds to maintain metabolic function in the colder temperature. Yeah, because if you had a purely saturated fat in the cold temperature, since the seeds don't maintain any type of temperature themselves, I'm talking about when they're going to develop to become a plant.
Mm-hmm.
Because I'm pretty sure when they're in seed form, there's not really much super large amounts of metabolic function going on.
Right. But not until it gets warmer. Yeah.
Not till it starts to hit the spring. But it's so that you basically don't have a solid fat that you can't do anything with. Yeah.
It needs to be able to be active enough to germinate and have those metabolic processes. And there's studies showing that the seeds that have to exist in colder temperatures have more polyunsaturated fats. And then vice versa, if they're in higher temperatures, they have less polyunsaturated fats, especially like tropical plants, which we'll be talking about. So they basically are this hibernation component for seeds that allows them to make it through the winter. And they actually serve a similar purpose in animals. So hibernating animals will eat these seeds. Bears are another good example where they eat a lot of the seeds and nuts to help increase their polyunsaturated fats. They'll also eat a lot of fatty fish like salmon. And so the bears use these polyunsaturated fats in order to put on body weight, put on body fat, and then also to slow down their metabolism so that they can hibernate throughout the winter. And then the same thing goes for other animals like squirrels that need to put on weight for the winter when food is a lot more scarce. They're eating foods like acorns, for example. So high polyunsaturated fat seeds that help them to put on weight so that they can make it through like a hibernation type winter. The next animal example in the environment that has a lot of these polyunsaturated fats are fish. And so fish, at least the ones that live in colder temperature waters, need to have a lot of these polyunsaturated fats so that they can exist, because again, these polyunsaturated fats are liquid at that lower temperature. And if you had solid fats in a fish, it wouldn't be able to swim too well. It would float up to the surface. It wouldn't.
It's essentially antifreeze.
Yeah, basically. So in nature, you basically have these fats that are meant to, for the most part, slow down function. They serve as hibernation type mechanisms, and they're very much associated with colder temperature organisms. And it's really the opposite with saturated fats. So saturated fats, as far as plants go, are found much more in tropical regions. So chocolate, for example, is very high in saturated fats, and coconut oil or coconut is very high in saturated fats. And of course, those are both tropical type plants that can have these fats that stand up to a higher heat or higher temperature, because if they were to have more polyunsaturated fats, they would become easily damaged, easily oxidized, and they wouldn't be able to survive very well. So then a similar function is found in animals as well, where because we have higher body temperatures, we're warm-blooded and we have higher body temperatures, we also need to have more of those saturated fats, because if you were to have polyunsaturated fats at 98.6 degrees Fahrenheit, you would have a lot of oxidation going on, and you see that in the human body. So essentially when we see saturated fats in nature, they're associated with warmth and then also with raising metabolism. So again, we mentioned that the certain animals that need slower metabolisms to get through winters through hibernating or putting on body fat, for example, they need those polyunsaturated fats. And then for animals who don't do that, they need more saturated or monounsaturated fats.
Yep. I think you summarized it pretty well. There's not much to add to that one.
Yeah. And so then from there, what's really helpful is to look at basically why these are the case, like looking at the physiology of polyunsaturated fats and saturated fats and how they carry out these environmental effects. So we talked about how polyunsaturated fats have those multiple double bonds, and that is responsible for a lot of their effects in physiology. And then there are some other things too that are important to consider. But I would say there are basically three reasons that allow for polyunsaturated fats to slow down the metabolism and lead to things like hibernation in animals and also increased body fat and things like that. And so the first one is that they're structurally weak. So we use fats in the structure of our cells for all sorts of different tissues, all sorts of different reasons. And the polyunsaturated fats are very structurally weak, so they have certain properties because of that. The next one would be that they're converted into basically downstream metabolites called eicosanoids, and these are mostly responsible for inflammation in our bodies. And then the last is that they are very susceptible to damage through a process called lipid peroxidation, and that leads to a whole host of effects as well. So we'll kind of go through each of those three and what that the effects of those on our health and on our physiology.
Okay. I mean, I think we already touched on the fact that they're structurally weak when we were discussing the double bonds in the carbon between the carbons and the fatty acid tails.
Yeah, and we did, but so there's some specific effects of that in the cellular structure. So when the polyunsaturated fats are integrated into the fats of our cells, which are used for all sorts of things, one of them is one of these functions is inside the mitochondria. They're used as a structural component for what they call the membrane, which isn't necessarily the membrane, but and then the same thing would go for the cells themselves and their membranes. So, which again are not necessarily membranes, but so it's been shown that when the polyunsaturated fats are incorporated as structural components, they lead to much less efficiency than the saturated fats, and that's because of their weakness, because their structure. And
so they create a more fluid membrane is, I'm pretty sure, the current working theory, right?
Yeah. And they talk about that more fluid membrane as being a beneficial thing because I guess they think about it on a very mechanical level where, if the membranes are very fluid, they're not going to get stuck in your arteries, and then it's not going to cause this blockage that leads to a heart attack.
And the cells aren't going to be too rigid to undergo metabolic function and thoughts like that.
Yeah.
But on the other side of the spectrum, if they become too fluid, you essentially have a leaky membrane. And I think that's where you're going to go, and that's where it becomes important.
Exactly. Yeah. So it's been shown that when these polyunsaturated fats are incorporated into the membranes of the mitochondria, they do have these leaky properties. So they increase the permeability, which is the leakiness of these membranes, which allows for protons to leak through. And the proton gradient in the mitochondria is what essentially allows for energy production in many ways. And so when you have more permeability, that's one of the best ways to stop energy production. You basically can't produce ATP. And so having more of these polyunsaturated fats into this mitochondrial membrane, which then leads to the increased proton permeability, very effectively disrupts energy production.
Yeah.
And then it also so the permeability is not just to protons, but also to different ions like sodium and potassium. And again, there are other properties of the cells that can kind of account for this. It's not necessarily a leakiness of the membrane per se, but the effect is the same. So you have this basically less stable cell that can't hold on to the proper ions in the right concentration. And so it essentially loses energy, becomes less efficient. And in order to maintain the same level of function, it basically has a much greater energy demand. So it would have to drive the metabolism much harder in order to have the same amount of energy.
Yeah. So essentially they're burning the same amount of fuel, but producing less energy from that fuel. So more fuel is required to burn. And
Exactly.
I think it's important to when we talk about gradients, or when you talk about membrane permeability, at least under the current, and this isn't like fringe alternative medical models of things. This is under the current paradigm, under the current mainstream accepted paradigm of how things work on a cellular level. You have a membrane, and to create a gradient, you have a certain number of ions on one side and a certain number of ions on the other side. Generally, one side is less and one side is more. And then what drives the energy production is the movement of those ions across the membrane. In the current model through mitochondria, the ions are moved through a protein or an enzyme called ATPase. And the movement of the protons through ATPase is what creates ATP it uses the electricity or the charge created by the gradient to attach one phosphate bond, a high energy phosphate bond is what they call it, to one ADP. So essentially, when the membrane starts to become leaky, the protons are moving back and forth across the membrane without moving through ATPase, and you're not able to generate the energy. You can't harness the energy. So it's literally a breakdown of the energy production. It's if you were trying to heat your house, or if you were trying to generate electricity by burning coal to create steam, and then have that steam drive some type of turbine, which is, I'm pretty sure, like one of either the older or one of the more general methods that electricity is created. It's like having all the pipes of the steam have holes in them. So as the steam goes through the pipes to drive the turbine, it's escaping.
Yeah.
So you're basically bleeding out all the energy you're creating by burning the coal. And it's not a perfect example, but the basis is there. So I don't want people to get too literal on it, but it's bleeding the energy that you're creating.
Yeah, or it's like, having the heat on in your house. It's winter, but you have all the windows open.
Yeah, exactly. There you go. That's better.
Yeah, and it's very disruptive. And this is and this isn't like a trivial thing we're talking about. This has actually been shown to be one of the primary, if not the primary factor that determines aging and lifespan between species. So they used to think that this was that if you basically, the higher metabolic rate you had, the faster you aged. And it's like a very old idea that has to do with a very mechanical view of the body. And I'll link to an article that I wrote that's dealing with that specifically. But what they have found since then, more recently, is that the saturation of the membranes in our cells is actually more of a determinant of aging and lifespan. And what they found is that the reason for that earlier connection between metabolic rate and lifespan is because for the animals that have much more unsaturation, much more polyunsaturated fats in their cell structure, they're so much less efficient with their energy production that they waste way more energy, so their metabolic rates are much higher. And it's not actually the higher metabolic rate that's the problem, it's the unsaturation that's the problem. And they know that because when they look at species, when they look within a species, so instead of between a species, when they look within an individual species that has relatively the same saturation of the cell structure, they found that the higher metabolism actually lives longer and ages slower. So when they look between species, higher metabolism seems to be problematic, but that's just because the less efficient ones have a quote unquote higher metabolism. It's not, I don't really consider metabolism in those terms. It's more just, in that case, it's just wasting energy. It's less efficient. But within a species, the higher metabolism is actually better, and the less unsaturation or the more saturation, the better. And there's really a huge difference as far as that's I guess that's part one is the effects of this structure on the efficiency of energy production. But there are other, those other two factors that we talk about also relate to this as well. So maybe we should just move on from there.
The other thing, just to add, when you have a high amount of polyunsaturated fats inside the cell, you can actually induce the swelling of the cell. And that swelling of the cell is it's like a direct signal to induce mitosis or cellular division, which induces a state of growth rather than a state of differentiation. So a state of growth is just the cell moving towards a more primordial state and then creating another cell, essentially a copy of itself. Whereas differentiation is that cell specializing to a particular function, say a liver cell or an intestinal cell or an alveolar cell in the lungs, whatever it is. So when you have the cells moving towards a more primordial state and just dividing, that would be more akin to cancer or a cancer type of metabolism.
Yeah.
And I think it's important to bring that there because outside of the mainstream model of medicine, when you start looking in the more of the alternative stuff and the structuring of water and the control of water and the gel states and stuff like that, when you start to induce swelling or leakiness of the cells, you start to move towards that more primordial state. And then even within the mainstream model of things, swelling of cells and things like that is associated with inflammation and energy failure.
Yeah.
You see that with heart failure. You see that with even all the stuff going on with the current pandemic and whatnot. You see that the lungs, when they start to have energy failure from a massive inflammatory response, they start to become swollen and edematous. You get pulmonary edema, and that is due to a direct energy failure.
Yeah. Yeah, the energy and structure of water in the cells very much goes hand in hand. And when the cell has the energy it needs and is producing energy efficiently, it has very structured water. And when it's not doing that, when it's disrupted in whatever way, that water becomes unstructured and that leads to swelling. And so you're just saying that the polyunsaturated fats are associated with that swelling.
Yeah. Well, the polyunsaturated fats can induce that swelling, I think, on multiple levels. Mm-hmm. Basically, since they inhibit energy metabolism to a large extent, you have like multiple factors going on, and we are going to talk about more as well. So the other thing I was going to say was, even when so they do induce the proton leak, but in doing that, don't they also induce a lot of oxidative damage from their effects in the metabolism?
Well, so their use as a structural component, I guess we'll go there next. So their use as a structural component is a problem even when they're not damaged, even when they're like perfectly healthy, I guess if you want to say. The fat is not damaged at all. It's fine. The weakness is still a problem. Mm-hmm. The next point, one of the next points is that yes, the polyunsaturated fats, because of their double bonds, because of their instability, are very susceptible to damage through a process called lipid peroxidation. And just to put this into perspective, and this varies between the different lengths of the polyunsaturated fat chains and how polyunsaturated they are.
But how many double bonds they have.
Right. But if we were to take, so the saturated fats are the least susceptible. Monounsaturated fats would be next. And so if we were to take one of the primary monounsaturated fats called oleic acid, and then compare that to a couple of the more polyunsaturated fats, so if we were to look at arachidonic acid and DHA, the arachidonic acid is about 160 times more susceptible to peroxidation than the monounsaturated fat oleic acid, and DHA is about 320 times more susceptible to peroxidation than oleic acid. So we aren't talking about small differences here. They're way more susceptible to this damage. Yeah. And then when you want to consider the fact that our bodies operate at 98.6 degrees Fahrenheit, ideally, at least, then that's a lot of oxidation going on. So yeah, even if they're not oxidized, they're a problem, but they're often oxidized, and that's even more of a problem. Yeah. Do you want? Yeah.
And being directly being incorporated into the cell and into the mitochondrial membrane, per se, you basically, those are spots where oxidation is most likely to occur, particularly at the mitochondrial membrane, because you have a whole bunch of electrons and different charges flying around. And when you have a lot of leakage and damage to the mitochondria, that the efficiency of that production or of maintaining the energy that is being produced through the mitochondria, it just goes haywire. And then all of a sudden you have electrons and oxidation products from the polyunsaturated fatty acids all over the place. So not only do their increase in fluidity of the membrane and causing proton leak and things like that affect metabolism, when you have the leakage and then the derangement in the metabolism, you start to put off, basically, I guess you would say, it's almost like when you first start a diesel truck and you get a whole bunch of black smoke coming out when you first start it up. You get a whole bunch of products coming out of the mitochondria when it's damaged, and then that directly goes and interacts with the polyunsaturated fatty acids and causes more damage overall. So it sort of moves into like a feed forward reaction and amplifies itself.
Yeah. And that's that lipid peroxidation of the polyunsaturated fats has been shown to directly disrupt energy production as well, especially at the level of cytochrome C oxidase by when cardiolipin is peroxidized, which cardiolipin is a fat component that when you eat more polyunsaturated fats, the cardiolipin becomes more unsaturated and more susceptible to that lipid peroxidation. And then you also have all of these other, like these downstream lipid peroxidation products that are associated with pretty much every disease and chronic condition out there. Everything from the brain degeneration in Alzheimer's and Parkinson's to diabetes and cancer and heart disease and all of those different, like, I think you would be very hard pressed to find any sort of
single disease. Yeah. Even autoimmune diseases, are strongly associated with lipid peroxidation products and the damaged polyunsaturated fatty acids. Yeah. I mean, when they test for inflammatory products or inflammatory conditions in a lot of studies, they're looking for maldialdehyde and then T-bars, thiobarbaric reactive species, which are breakdown products of the polyunsaturated fatty acids. So
yeah. So yeah, and yeah, I guess I don't even know what more to say there. It's overwhelming the evidence there that those things are problematic,
and
and
if
the
you track
only
historically, go ahead. I'm sorry.
well, I was going to say the only argument you can make that the polyunsaturated fats themselves are not an issue is that lipid peroxidation only happens when things are deranged. And it's true that it happens way more when your body is not functioning properly, but it still happens a considerable amount anytime you have the polyunsaturated fats. And if your body is not functioning properly, that's even more of a reason to have less of the polyunsaturated fats, because that means that you're even more susceptible to that peroxidation.
It's like loading your cells up with dynamite and hoping that the fuse never gets lit, even
Exactly.
though your body runs at temperatures high enough to light the fuse.
Yeah, and it's always getting lit. It's just a question of like how much. Yeah. I mean,
and if it, exactly, yeah. And we, especially considering that we run at 98.6. Ideally, our body temperature should be functioning at 98.6
or higher.
So we're at temperatures where those fatty acids start to have issues. It's not like oh, you have to go up to way higher temperatures. It's not like it. No, at the level that we function at, there's issues right there. You don't need to go too much further. And then when you start adding insults to injury like endotoxin or any type of inflammatory reaction from your diet or irritation or things like that, or a viral infection or something like that, then you basically have the fuse to you light the fuse, and then you have these massive issues, and you see heart disease, cancer, diabetes, autoimmunity, massive inflammatory conditions, ARDS, things like that. This basically runs through these pathways, through these inflammation pathways, and the damage of the polyunsaturated fats at the cell and things like that.
Yeah. And another thing too is that that's all assuming that the polyunsaturated fats that are being eaten are already not oxidized. But a lot of times, if you're getting them in any sort of oil, like any sort of nut or seed oil that is mostly polyunsaturated fats, and then that alone will already have a lot of lipid peroxidation products. Then if you cook it, you're creating even more of those.
Yeah.
And even if you're looking at uncooked like omega-3s, for example, fish oil, they found that, almost every fish oil supplement has a pretty decent amount of peroxidation going on. Yeah. And so it's, again, like if you're already ingesting the peroxidized polyunsaturated fats, and then it's just going to, that process is just going to continue. So,
yeah.
And then,
I mean, there's studies showing with supplementation, I think this was in women. I think I sent you the study where they gave them I think it was an omega-3 supplement, and their vitamin E status decreased, and they had it in some of their antioxidant enzymes were compromised to some extent.
Yeah.
And that's so like perhaps their cholesterol goes down, but their entire antioxidant system and protection against lipid peroxidation gets corrupted. And it's like, you really have to start looking at, well, what are we doing?
Yeah. And I've seen quite a few studies that I reference in my article on omega-3s that show that ingesting fish oil is directly correlated with increased lipid peroxidation products inside the body. So
yeah,
it's not trivial at all. And then one other thing that we didn't talk about, again, even when the polyunsaturated fats are not going through this lipid peroxidation product, even when process, even when they're still intact, then they get converted through different enzymes, LOX and COX that we've talked about, to different eicosanoids. So
and prostaglandins.
Yeah, prostaglandins and leukotrienes, which are under the eicosanoid umbrella. And they're basically responsible for all of the general inflammatory processes, or signals, I should say. Like, they are basically inflammatory signals. And of course, you don't want to be encouraging the triggering of the production of any of these, but also when that trigger happens, the more polyunsaturated fats available, the greater amplification of that signal you have. So it's basically like if that signal is going on, which you already don't really want, there's this misconception that inflammation is a major part of healing and of the immune system, and that's really not the case, or at least doesn't seem to be the case. So what you're really doing is amplifying the signal of disruption, of damaged metabolism. And we obviously don't want to be doing that.
Yeah. So basically, to summarize, the less polyunsaturated fats you have in your tissues, the less conversion you have into inflammatory mediators like prostaglandins and leukotrienes under the eicosanoid pathway. And if I'm not mistaken, a large portion of the inflammatory mediators come from that pathway. So just lowering your polyunsaturated fat intake and moving more towards saturated fats and replacing those polyunsaturated fats, if you've been eating them for an extended period of time, with saturated fats, you can just lower your inflammatory burden just like that in general.
Mm-hmm.
So, and I don't know if you want to move on to the next point, but I think it's important to understand why the whole heart disease and cholesterol hypothesis as to why the polyunsaturated fats have been promoted so strongly. Yeah. And then when you look at when they started introducing the polyunsaturated fats into the diet, mm-hmm. and you look at heart disease and cancer and all these different types of diseases, they track like pretty closely. A lot of people like to put it on sugar or added granulated sugar and stuff like that. But when you look at that, at the actual graphs, they don't really track very closely to each other. Whereas sugar intake starts to drop off, I think around the early 2000s when they started doing the anti-sugar stuff. Mm-hmm. And then you basically start to, the obesity and heart disease trends and things like that are still increasing. So
polyunsaturated fats were never really a major part of our diet. They've become a huge part since everything has transitioned away from the saturated fats, away from butter and beef fat, which McDonald's used to cook their French fries in beef tallow, for example. Exactly, yeah. But now everything has moved towards soy oil and canola oil, and so the amount of PUFA
has drastically increased in the diet.
Exactly,
to ridiculous levels from what it was prior to that.
Yeah, and so when people want to blame some aspect of our diet on all of our current health issues, a lot of times they go to sugar and point out some association between increases in sugar in our diet and increases in polyunsaturated fats, and increases in chronic health conditions. But if you look at the trends with polyunsaturated fats, I think it's much better for explaining.
Yeah, the line is a better fit.
Yeah.
So I just want to point that out. Before we get there, you start, because when people don't understand, I mean, earlier, and I think in the early 1900s and then in the late 1800s, autoimmune diseases and cancer were relatively unheard of. It was like you come into the hospital and somebody has an autoimmune disease or a cancer or something, and all of the physicians go in because it's like a learning experience. Now it's commonplace. I mean,
even for young people.
Yeah. In the hospital, cancer is common. You see it in tons of patients. Diabetes, heart disease, autoimmunity, very, very common. Everybody's coming in with some type of autoimmune disease, whether it's psoriasis or whatnot. So the diseases weren't there. They weren't there back in the day. A lot of people like to say it's because the lifespan was so short and things like that, which, I mean, there's a lot of arguments against that. And we won't go into them now because we don't have so much more time, but essentially these diseases didn't really exist to the extent that they did until these quite a few things happened to the food supply. But one of the major ones was the introduction of polyunsaturated fatty acids, and the basis for introducing them was under the understanding that polyunsaturated fatty acids lower cholesterol. And that was the idea behind lowering cholesterol. Was, I think, the Ansel Keys' studies, what was it, the 7 countries or something like that?
Yeah, well, it started as 22 countries. It ended up as 7 countries because he didn't like the data from 15 of them.
Exactly. And then basically what he showed was that the higher intake of cholesterol and saturated fat led to more heart disease. So then they started replacing the cholesterol and saturated fat with polyunsaturated fat. And so that's where the recommendation initially came from. And then obviously everything followed that because there was a huge industry push behind it. Which is important to note. And then we started introducing these types of fats. So it is true that polyunsaturated fats lower cholesterol. However, the mechanism of lowering cholesterol is always important. Now, this isn't to say that high cholesterol isn't a problem, because high cholesterol is a problem, but not necessarily due to the cholesterol itself, more so to why is the cholesterol elevated in the first place. And it can be from an infection. It can be from any type of thyroid disorder. It could be from any type of metabolic issue or conversion problem with the cholesterol, things like that, or like a liver problem, anything like that. So it's more, we want to look at what's going on specifically with why the cholesterol is elevated, not just lowering it and treating the cholesterol as the initial problem. And when you start to look at some of the studies of how polyunsaturated fats lower cholesterol, and I think before I get to that, it's important to note that most of the cholesterol that we have in our bloodstream is produced by our liver.
Yeah, it's not adjusted. The association between ingested cholesterol and blood cholesterol is essentially not existent.
Yeah, you'd have to eat massive amounts of cholesterol to see any real big difference in blood cholesterol because your liver adjusts production. Go ahead.
Yeah, well, I mean, even there, blood cholesterol is like the production of cholesterol and blood cholesterol aren't necessarily even related because that has more to do with how much cholesterol is let out into the blood and not taken back in, as opposed to how much is in existence inside the body. Like cholesterol is used throughout all sorts of our systems.
It's not only a bloodstream product. I mean, it's all over the place.
Yeah.
So
sorry, I interrupted you. So go ahead.
No, it's okay. So basically, then the real question is, how is polyunsaturated fat actually lowering the cholesterol? And there's some studies basically showing that the lowering of cholesterol is due to damaging some of the cells in the liver's ability to produce and export the cholesterol.
Yeah.
So that's not really a great mechanism and it's due to the peroxidation products. It's not really a great mechanism to lower cholesterol. It's not really how you want to go about lowering cholesterol. So we're not saying that high cholesterol is not an issue, because it is indicative of an issue. But the cholesterol itself is not necessarily the issue. So then when you move on to heart disease, your polyunsaturated fats do lower cholesterol. But there's a lot of evidence coming out now showing that the more polyunsaturated fats you have in your tissues and then also within your cholesterol, particularly LDL cholesterol, the greater increases you have of damage to the vasculature from the oxidation products of the polyunsaturated fats in the cholesterol. So yes, we're lowering your cholesterol because the current model is basically the more cholesterol you have, there's almost like a gradient for it to be pushed into the arterial vasculature. And then that gradient, so basically the more you have pushed in, and the more plaques you develop. I don't think that's necessarily how it actually works. I think the damage, first of all, you have what's causing the damage in the vasculature. From my reading, my understanding, I would say it's most likely endotoxin and polyunsaturated fats currently. And then any types, there's heavy metals and things like that can cause damage as well. And then the next piece is, okay, if you have damage to the vasculature, well, how do you generally repair that? And if you look at any of Linus Pauling's work or anything like that, vitamin C is the cofactor for the enzymes with copper and certain amino acids like glycine, proline, and what's the other one? Alanine. Then basically what you see is those are the cofactors for collagen production and the building of the vasculature. When you don't have enough of those on board, particularly vitamin C in the modern diet, you can start to see issues with the fixing of the damage of the vasculature. And then with a high amount of polyunsaturated fatty acids and a diet that produces a lot of endotoxin, you have a combination of a high insult to the vasculature with a low ability to repair. And then basically, I think that's where you start to see the heart disease coming in.
Yeah. Yeah. And those things that you mentioned, like endotoxin or lipopolysaccharide and polyunsaturated fats, are shown to be found to be directly implicated in the plaques in the arteries and those kinds of things. Like they find them in the plaques. So the evidence is pretty strong for that. And when we're talking about the effects of fats on cholesterol or anything on cholesterol, it's not as simple as just total cholesterol. There's also this breakdown between HDL and LDL, and we won't get into the all that too much now because it's a whole other topic. But the mainstream, I would say, kind of has it backwards. And so yes, the polyunsaturated fats will increase the HDL and lower LDL. And if you again, this is the issue with not looking at the greater context and how they do it and why they do it and the purpose of those different protein carriers of cholesterol. And so if you look at other things that also increase HDL and lower LDL, you have known metabolic toxins like alcohol, which directly damages the liver, or you have estrogen and excessive amounts of stress, and all of those kinds of things will all increase HDL and lower LDL, just like polyunsaturated fats, and they're known to be metabolically toxic and liver toxic. So just looking at anything with that sort of reductionistic view that, cholesterol seems to be associated with these issues, like high levels of cholesterol, so anything that lowers cholesterol is beneficial. It's the same misguided approach to diabetes, where we see high blood glucose in diabetes, so it must be causing it, and that must be the problem. So we just need to lower the blood sugar. It's when you look at things without the greater context and understanding what leads to the increase in blood sugar, what leads to the increase in cholesterol, and also why. Because you actually begin to recognize that the increases in blood sugar or the increases in cholesterol are protective effects. They're actually preventing some of the damage that would happen because of the underlying issues going on.
Yeah.
And so by having this reductionistic approach of, we just need to lower the cholesterol and that'll fix the problem, often makes it way worse.
Yeah.
Same thing with the blood sugar potentially. So go ahead.
Well, I was going to say, I think it's just in general, the LDL is being exported from the liver to the tissues, and HDL is being transported from the tissues back to the liver.
Right.
When your cholesterol is based, as we said, it's in all tissues. It has very important structural functions. It's also the precursor to all your hormones, your steroid hormones like testosterone, estrogen, progesterone, cortisol. So when you basically, and those are all extremely protective factors and have multiple functions in the body, different effects depending on what they are. When you start to shortchange that stuff and you start to lessen the cholesterol and things like that, that causes issues in and of itself.
Mm-hmm.
So
a lot, yeah.
Yeah, exactly. And then the other thing to take into consideration is, why is the LDL picking up the cholesterol and bringing it back? And in some of the studies that I've shown is that the LDL basically has some detoxification functions for lipid peroxidation and things like that. So as far as I can understand from my current reading and my current view and whatnot, I would say that the LDL is elevated with the high polyunsaturated fatty acids because it's actually picking up peroxidative products and bringing them back to the liver to be detoxified, because you can't leave them out in the body. They're damaging. So
you mean the high HDL?
HDL.
Yeah.
So there's, did I say LDL?
I think you said LDL, yeah.
Oh, yeah. So HDL is bringing the peroxidated products, peroxidated fatty acids, back to the liver to be detoxified, because you can't leave them there structurally because they are damaging in general. Right. So basically, if you have what you want to have is you want to have ample amount of LDL, and you want to have your metabolic function well, so that you can be using that LDL to convert it into the downstream steroids by transporting it to the mitochondria. So you want to get that system to work. You don't just want to lower cholesterol as some sort of random endpoint and then say, okay, we're all good now. And then that's where you start to see things like with the usage of statins, which was a whole different topic. But
yeah, and that's why you see that's why LDL is increased in the first place, much like blood sugar, is that when metabolism is lower, the thyroid's disrupted, things like that, the higher LDL helps to increase more cholesterol transport to the tissues, increases steroid production. It also functions with our immune system. And the same thing with blood sugar, where when your cells aren't able to use the sugar as well, elevating the blood sugar is a way to kind of force it a little bit better and at least get some amount of glucose oxidation, some amount of energy production. So, there's so much more to dive into all those, and we'll have to leave them more for the future. But to kind of wrap up at least for today, the present, consuming polyunsaturated fats is probably one of the major factors in damaging our health, and one of the things that we want to avoid more than anything else, as it has one of the most impactful effects on our metabolism. And so again, that just means avoiding the vegetable oils, nuts and seeds, fatty fish, and also the fats from chicken and pork that are grain-fed or that aren't pastured. And then instead favoring monounsaturated fats like olive oil, avocado or avocado oil. And then you also mentioned macadamia nut oil or macadamia nuts. I actually like
macadamia nut better than olive and avocado because it has significantly less PUFA than those two.
Sure, yeah. And there's other benefits to olive oil, for example, a lot of the polyphenols, and you do have vitamin E in there.
Polyeuropean or whatever.
Yeah, but again, you wouldn't really want to cook with it per se. You could.
Or macadamia oil.
Yeah.
You want to cook with any of the monounsaturated. I would add them after.
Yeah, I would focus on, as far as cooking goes, using saturated fats. So coconut oil, butter, beef tallow. You could use like some
butter.
Yeah, cocoa butter, some palm oil variations. And again, there's many more details there, but in general, favoring the saturated fats and monounsaturated fats over the polyunsaturated fats makes a pretty huge difference.
I think it's important to note too, most of the saturated and monounsaturated fats that we listed are traditional fat sources that have supposedly been used for centuries by populations across the world. Yeah. The newer fat sources, canola, soy, safflower, sunflower, corn, those weren't introduced into the public or used on a broad scale until, I don't know, the 1940s, 1950s is when they started picking up production. And it started in the US and then now it's expanding across the world. But the other fat sources were the ones that were mainly used. I mean, ask your grandma, she probably used butter.
Right. Yeah. And to add to that, I missed a couple other saturated fats, but and any ruminant animal fat, so beef or goat or bison or anything like that. I think that was pretty much everything. But yeah, these were all used more traditionally, and only recently have we started using the polyunsaturated fats. So yeah, I think we'll wrap it up there or leave it there.
Yeah, perfect.
All right, I hope you guys enjoyed that episode on the different types of fats and the harmful effects of the polyunsaturated fats. I did want to mention one thing that I had forgotten at the end, which was that dairy fats are another really good source of the healthy saturated fats. And so that would be from milk or cheese or butter, which we did mention butter. And then eggs are also another good source of saturated fats that I know we mentioned earlier, but just to reiterate again. So I hope that was all helpful for you. If you did enjoy this episode, please leave a review or a like wherever you're listening. It really does a lot to help out the podcast. To check out the show notes for today's episode, head over to jfeldmanwellness.com/podcast, where you can check out the links and articles that we referenced throughout the episode. And at those show notes, you can also sign up for the free Energy Balance mini course. And in that Energy Balance mini course, I'll be walking you through the different things that you can do nutritionally, but also as far as things like exercise and stress go, in order to support your energy systems and get rid of any low energy symptoms, whether that's fatigue or brain fog, gut issues, weight gain, and also any chronic health conditions that are a result of a lack of energy, whether that's diabetes or heart disease or autoimmune issues. Head over to jfeldmanwellness.com/energy to sign up for that free mini course, or you can also do that at the show notes at jfeldmanwellness.com/podcast. And I will see you on the next episode.